Hi there, this video is to demonstrate collision detection and resolution in my game engine I've been working on. It's all programmed in C++, and initially I was using SDL2 for the graphics, but I've since switched over to DirectX 11 and DirectX TK. The goal initially with this was to give myself a good basis for my engine. So initially the goal was to have circles, rectangles, ellipsoids, and be able to do axis aligned and object aligned bounding boxes, so rectangles. And as we go through, we'll go through and see what problems I encountered. So at the start here, we just have two circles collision detection. So this is obviously the most straightforward case. We're just comparing the distance between the centers of both circles versus their radiuses to see if we have a collision. And now I'm enabling resolution here. So basically just at each step, each iteration, we're checking to see if that collision has occurred, and if it has, I'm creating a resolution vector using the vector between the two centers, the distances between the two centers, and the radiuses. And that equation I found to be pretty easily Googleable. Before we move past circles here, I wanted to bring up ellipsoids. So as I mentioned at the start, I was hoping to be able to detect ellipsoids. And I was pretty excited at the beginning, actually. I thought it was really cool learning that you can treat them as unit circles, then they apply the radius depending on the location of the adjacent objects. But when I went to find methodologies to detect collisions, I was actually kind of disappointed because most of the results I found depended on the velocity of the ellipsoid, which, depending on your engine, I guess, could be not a big deal. But to me, I found to be disappointing because I really didn't want any dependencies. The most obvious case of an issue would be if you spawned an ellipsoid and it was in collision, then it wouldn't be able to be detected, right? So I ended up leaving the ellipsoid at the wayside, and at that point I started to really think about what exactly I wanted an ellipsoid for, and ended up realizing that there really wasn't much of a use case for it to begin with, other than personal interest. So here we're moving into a rectangle, or in this case, a square colliding with a circle. And we're still just doing the detection. It's a bit more interesting. For this, just to keep things simple, I ended up just going through the square and finding the closest point on it, and then seeing if that was within the radius of the circle. I think that there might have been a more efficient way to do it using a separated axis theorem, which I'll use later on for the two rectangles, but I was pretty happy with the results here. You can see it's fairly accurate. Um, you might have been able to tell based off my ellipsoid discussion, I was kind of beginning to realize that practicality is kind of the most important thing when it comes to uh, this collision detection versus mathematical accuracy I was kind of hoping for. And here we're moving into the resolution. And as I forgot to mention earlier when we started just the detection, you can see here that I'm doing any angle, so not just axis aligned, but also object aligned. So when it comes to the resolution here, I'll replay the same clip here, but what I'm doing is I found the closest point on the square like we did in the detection, and then if there is a collision, we're going to compare that with the radius and move or create a resolution vector large enough so that that closest point is now outside of the radius. Pretty straightforward. It would have been interesting to do something adjusting the angle, but in the name of simplicity, I just stuck with the resolution vector. So I ended up forgetting to collect footage of just the collision detection for rectangle, so this is the resolution. But for the detection, as mentioned earlier, I ended up using a separating axis theorem. There's lots of stuff online about it, basically just checking to see if a line can be drawn between the two objects, which is obviously simpler if you have axis-aligned bounding boxes versus these object-oriented bounding boxes where you have to check the faces new angles versus just the two XY Cartesian ones. So one interesting problem I found here was uh, how to represent these boxes once you begin to introduce this new angle. You learn in computer graphics to use a homogeneous transform to efficiently rotate the objects. But in this case, we don't have that. So it ends up being rather inefficient what I've done doing the sinusoidal calculations, which is a pain in the butt. But I thought that was kind of interesting to think about. And speaking of pain in the butts, resolving this collision with when you start using angles became an issue for me, and I had a difficult time finding anything online that really solved it. Um, so my super inefficient solution, which ended up being semi-accurate, was you find the closest point on the red box, the offending box, and then from that you find the two closest points on the white box to that point on the red box, and you push it out so that that single point is not colliding with the line drawn between those 2 points. And that works well when the box collides with the face like there. But once you start having a corner, it needs to be pushed out past that 1 point, which it doesn't do. So this ends up coming to the conclusion here of kind of what I've learned. The first thing being that practicality really trumps accuracy, and especially if you can run efficiently, then that speed really tricks the human eye over pinpoint accuracy. As much as this is kind of the opposite of what my mathematical brain would love to have. And along those same lines, I'm kind of forced to draw the conclusion that just using circles and simple axis aligned bounding boxes is kind of the best idea just to keep it simple. Obviously, I'm not creating anything industry grade, I'm no expert, but that's just what I'm kind of seeing. And it seems like you could do stuff like multiple bounding boxes for a single object or hierarchical bounding boxes to get more complex. And that way you're not having to calculate all the angles every single time and add that overhead to every single iteration, right? But once again, that's just my conclusion. And I think probably the final unfortunate conclusion I have to draw is that you'd be better off using somebody else's tried and true collision detection and resolution system than making your own. But it's been lots of fun to learn and program, and hopefully you guys enjoyed this video. Thank you for making it this far through. And on that note, see you later.